Hey, Nathan here. Welcome back to another tutorial. In this tutorial, it's going to be the first tutorial of the new artificial intelligence series. And as I mentioned in the introduction, if you haven't watched that, I know a lot of people don't usually watch those because nothing happens. But the whole purpose of this series is to relook at or improve on the existing artificial intelligence concepts we discussed in the last series, and also discuss new and more complex topics. For this tutorial, I didn't want to start the series off by doing the same thing we've discussed before. So this is a brand new topic. It's a pretty simple topic on the high level overview of it. But as your game gets more complex, it really turns into a spider web of transitions. So this is a concept called Finite State Machines. You can implement this in multiple ways. This will be a high-level overview of basically what's going on. And I've taken an approach. I'm looking at a real-life example of what I think is going on in the code. It's a actual game. It's not something that I wrote, so I don't have access to the source code. I can't confirm it with 100% that this is exactly what's going on. And as a fellow developer, I don't want to kind of hack it and decompile it and that kind of thing. I am appreciative of somebody's work, and I don't want to deconstruct it and, not offer the source code, but to discuss the source code. I just find that I don't want to do that as a fellow developer. I can appreciate somebody's work and just look at it and kind of think about what's going on. So just a disclaimer, this might not actually be what's going on, but throwing in this concept on this game, we can kind of get what's going on, and we can kind of apply it in a similar game looking at this example. Okay, so what is the topic? The topic is finite state machines, and this is essentially controlling object states that have exit conditions and, in terms of a different state, entry conditions. For example, let's throw up a state on the screen. We'll call this wander. And these states can be actually artificial intelligence concepts like the wander. We know what wander does. But this can be different from game to game, as we'll see in the example. We're not just wandering infinitely. There's no downtime like in my wander artificial intelligence video. In some games, we might wander on a path. It might be a path we follow and stay at the endpoint for like 30 seconds or so and then go back to the path. So this isn't just the actual artificial intelligence concept. This can be whatever we want to implement in the state. You can use the wander artificial intelligence concept, but it's not necessary. So the state name is just coincidence of what the artificial intelligence concept is. Okay, so this is pretty self-explanatory if you've seen the wander artificial intelligence, and based on the name, we're just going to have the object walk around, and that's it. Now, that's not very useful until we throw in a second state. So let's call this investigate. Now, going from one state to another state. From the original state, we'll refer to that to an exit condition. Now, taking the approach of separation of concerns, we don't want the new state to know about the previous state. So we won't have a kind of an entry transition. So we'll just refer to these as exit transitions. We're going from one state to another state. That kind of keeps things nice and clean. A good example of this is we don't want the investigate state to determine when it gets active. We want the wander state, which has its own logic. We want the wander state to know when to push the investigate state. So we want to transition from. Okay, so wander exit states to investigate. So what are these? And investigate, we can have our own logic in there. What we are investigating in terms of the actual example that I'll show soon is we are trying to look for the player. It's a stealth game, so we're trying to look for the player. So, when do we go from wander to investigate? Let's throw up a exit state. Player is partially visible. So, if something is seen in the distance, the enemy sees something in the distance, there's a field of view for the enemy, and then there's like a secondary field of view. That's the enemy is too far to determine that this is an enemy. It might be I'm going to refer to the enemy as we are actually playing the game, and I'm not going to go mix those words. So I'm only going to do this. Enemy will always be the bad guys, and player will always be you. Okay, so the field of view for the enemy is like a close range field of view where you know the player is the player. There's going to be a secondary field of view where the enemy doesn't know that it's an actual player. It might be some kind of animal or something that it sees in the distance. So they get to a caution state, or we'll call this investigate state for the finite state machine, where the enemy thinks it saw something. It doesn't know it's a player yet, so it just gives them heightened. It's basically wandering with heightened state. We want to go to where we found something. So it's basically wander plus kind of pushing the enemy to the location where it thinks it found something. And then we will investigate. It depends on how far you want to go. Do you want to look under boxes or that kind of thing? That will be on the investigate state. Another one. Not only visual sense, but the audible sense. What if we hear like a footstep or somebody knocking? Obviously, we want the enemy to hear that and try to investigate where it heard that noise. It's kind of like if you hear a loud bang, like you're watching this video, it's a watching state. If you hear a loud bang in your basement or somewhere else in your house, you probably want to change your state to investigate. You want to see what that bang was. So we hear something, we move from wander to investigate. We're basically going to do the same thing, go to where we heard the noise, and investigate. Look under boxes or on top of crates or that kind of thing. Depends how far deep into the game you want to go. Or if you just want to look around and see if you find the player, that's another option. Okay. So those are the only two that I wrote down in this example to go from wander to investigate. Now, like I said, we don't want the investigate state to determine when it becomes active, but we do want the investigate state to determine when to make wander active. So we don't want to go both ways. We always want to have one state determine when a new state pushes. We don't want a new state to determine when it becomes active. So that's the differentiation here. So we're only going to have transitions in one direction. So investigate. We are going to go back to wander if we found nothing. We looked in boxes, we looked on top of crates, we looked around corners, we didn't see anything. So do that for like 30 seconds, look around all these various places, look in corners, look in closets, if it's a game with rooms, that kind of thing. If you found nothing, why would you need to investigate for 20 hours? So we're going to go back to wandering in a certain time period. That can be determined in the code, but we're just doing this as a high-level overview. So we found nothing, we go back to wander. Okay. So those are all the connections on those two states. Let's throw up a new state. Attack. Alright, so we are currently in the wander state. We are going in our path. We are just going about our daily routine of just walking around this building or whatever. One way to go from wander to attack is when the player is found. Now, I just grouped these into one thing. Player is found. You could make them aware by knocking or by stepping your footsteps, or just be in their visual field of view in very close proximity. So I just grouped those into one thing. Player found. So we are wandering and player is found, so we are immediately going to attack. We have no question. That's a player. We are attacking. Go for it. So that's the only transition we go from wander to attack. Now, we are in the attack state, so let's go away from attack. So we don't want to go directly to wander, because we've seen the player. We know the player exists in this world. We don't want to go back to wander, so we're going to go to investigate. Now, how are we going to go to investigate from attack? We do that transition when we've lost the player. We no longer see the player or hear the player. We can't find the player where we were attacking them, so we're going to investigate. And this, again, how complex you want to be in your code. You might want to throw a different transition, heightened investigate. Or just go to the basic investigate. So we'll do the same thing, look in closets, look in boxes, look on top of crates. Just try to look for the player. If we find the player, again, we go back to attack. So player is found. So attack only gets entered from wander or investigate. Now, let's throw up another state here. And this will be the last state in this example. We'll call this flee. Now, this isn't really necessary. I don't see many games implement this too much. But remember, we are looking in this in the terms of the enemy. So we're wanting the enemy to flee. So when we are attacking the player, this will only come from the attack state. When we are attacking the player, we will flee only when the health is low. Only when we have like 1 or 2 hits left. Then we will flee. We don't want to get attacked anymore. You might want to throw up another state for like get cover or something like that. Or you could just implement that into the attack algorithm of your game. But flee will be a different state. We will exit the like the room or whatever. We won't wander because our health is low. So we won't have anything going from flee to anywhere else. Our health is too low. We're going to get out of there. Now, if you have in your game where you flee, you gain health, and come back, you can have a transition for going from flee back to wander or something like that. Alright, so let's take a look at an example of one of my favorite games of all time, Metal Gear Solid. It's a stealth game, so obviously what we looked at earlier kind of resembles what we want to do. We want to avoid being seen or heard. So that's why I threw up those player is partially visible or a noise was heard for the wander states and going from that to investigate. So as you see on the top right of the screen, that's the mini-map. We can see enemies, and our location is usually at the center of the mini-map. Now, currently the enemies are in a wandering state. Again, I can't confirm that I don't have the source code. So, I'm avoiding, like the footsteps I mentioned, this is a water spot. So if I run into that, I'll be heard. So the enemies are going in a certain path. They are wandering. And you can see their field of view is the little cone in the diagram there. Now, I need to avoid being seen or heard, because that will throw them into investigation. And if I'm close by, when they see or hear me, they will immediately go into the attack state. And right there, right here, I ran into the puddle of water, and they heard me. So at this point here, they went into the investigation stage. They heard something. They weren't sure if it was a player or not. So they went to the investigation stage. I kept running into the enemy further up, and they visually saw me, and they went into the attack stage, or what they call alert. So they're attacking me, and I believe I die. So another example, I think I get caught again. Yes. So they went from investigation to attack. Okay. So here we are. Now they're in the investigation. And like I said, you might want to throw in another state, because this is more of a heightened investigation where they're looking for me. In the second game, Metal Gear Solid 2, they have I think it's like a 2-minute caution stage where they do the actual investigation for like 2 minutes. And that's more of a heightened investigation, because if you knock or are partially visible, they don't spend 2 minutes investigating. So finite state machines on a high level, that's an interesting concept, and we can see kind of what appears to be going on in the background of the game that I just showed. And it can be very complicated. We're just worried about the states. What's in the state can be completely up to you. One person's investigate state might just be look for player visually. Another developer's investigate state might throw in more in-depth, like looking for the player in closets, looking for the player in boxes, looking for the player under the bed, trying to hear the player. They're more aware of what's going on noise-wise, that kind of thing. You might have players that look for the enemies that look for the player with thermal goggles or that kind of thing. So it's completely up to the developer. This state is a high level. It can be basic for one developer or very, very, very complicated for another developer by using this same diagram that you see here. And not only that, but you can also throw in conditions for the exit transitions. For example, let's say we're going from wander to investigate based on noise. We can throw in more details about not only where it heard the noise, but what kind of noise. If, like in my example, I was walking around and I stepped on a puddle. They heard where in the general area that noise occurred, but the type of noise was a puddle. So they can narrow down. So they heard this noise in this corner somewhere, but it was a puddle. So it's a pretty large corner. But we can narrow down where we want the enemy to go by saying it was a puddle. And there's just a small area of water in the corner that's a puddle. So we can narrow it down a very large corner, but a small section of that has water. So we can just isolate to that small section to start and then branch off from there to do the actual investigation. So we can throw in more details when we transition from one state to another state. Like the player partially visible example. It doesn't have to be like a 2D type of, like if you're working on a 3D game, it doesn't have to be like a 2D style of where the player was. You can have 3D. Did we see him up top or down below? If we think we saw something down below, we'll look under, look under beds, look under boxes, and that kind of thing to start. And then we'll look on top of crates, on top of stuff, if we can't find it in our initial investigation. So that kind of thing. Whereas one developer might just say, yeah, the player was partially visible in this general location, and they can just search. They might start the search from on top of the crates when the player was partially found under a bed or something like that. So you can throw in more details when we go from one state to another state. We can give more details to the algorithm as to what occurred, and it can help the algorithm. It depends on how difficult you want to make the game, or in some people's perspective, how fun you want to make the game by making it difficult, by having it narrow down so much. Alright, I think this is about it for this video. I hope you enjoyed it. We'll go into the actual algorithm and discuss a few things in a later date. I just wanted this to be a high-level overview of finite state machines, and we're already about 30 minutes, 25 minutes into this video, depending on how much I cut on it. So we'll actually go into the coding, but the actual algorithm for finite state machines itself, it's going to be pretty basic. It's just going to basically hold what state we're currently in and have a reference to that kind of function. This finite state machine should be abstract. The enemy has knowledge of how it wants to wander, how it wants to investigate, how it wants to attack, and how it wants to flee. But the finite state machine is just going to have a transition with data and what the current state is and how to kind of call that state. So we'll have delegates involved in that. Alright, thanks for watching. Next tutorial, we're going to take a look at enhancing the Wander artificial intelligence. And we're going to enhance that by kind of influencing where the object travels to push it to locations it has never been to before. So stay tuned for that, and I'll see you next time.